Solve quadratics by factoring ax squared plus bx plus c. This section is just an extension of the last one. In the last section, our leading coefficient was always 1. In this section, it is not going to be. And when that leading coefficient is not 1, it throws a bit of a wrench into our plans. It requires a little more work and some trial and error. So that leading coefficient is not 1. Okay, so first we need to tackle factoring out a common factor. So that is always our very first step. Whenever I'm factoring, the first step in factoring is always, and this often can be a step that people forget, and it can simplify a problem so much. The very first step in factoring is factor out common factors. Okay. So the first thing I do is first identify my terms, because I kind of have to know where my terms are. So in this situation, my two terms, 3x to the second and 9x, and we look for things they have in common, basically common factors. So if I have numbers, I would need to be thinking like, what are the factors? What are the factors of 3, 1 and 3? What are the factors of 9? 1 and 9 and 3 and 3. Well, they do have one in common. Now, you don't necessarily have to do this t-chart each time. If I know my multiplication well enough, I can know that 3 is the largest factor in both. So 3 is a common factor, but then they also both have at least one x. This is x to the first, and that one's x to the second. The biggest x's they have in common is just an x. So now I'm going to do the undistribute. So we're going to use the distributive property backwards. So I ask myself, 3x times what gets me this first term, 3x to the second? Well, to multiply, I'm missing an x. So I'd be missing an x there. And then there's my plus sign from here, plus sign. Now 3x times what gets me 9x? I would need to multiply by a 3. So here, I have now factored this by just factoring out that common factor. I now have factors of 3 and x. So these are technically two separate factors, 3, x, and then x plus 3. Those are my three factors that if I multiply them out, if I multiply the 3 and the x, I get 3x. If I distribute this in, I get back to where I started. And these are always, and then I always double check to make sure, do these have anything else in common in here? An x and a 3? Nope. So that's as far as that goes. So that is always our first step in factoring, is factoring out that common factor. So here in this first task, we have a flag. An expression for the area of a flag is given, where x represents the width of the flag. So I'm going to go ahead and I'm going to sketch my flag. I know x is the width. We don't know the length. So we want to first find the greatest common factor of these. So the greatest common factor. So first identify my two terms. 5x to the second. Technically, this is a negative. We write that as a plus, negative 10x. So their greatest common factor. Well, the factors of 5 are just 1 and 5. The factors of 10 are 1 and 10 and 2 and 5. So they do have one in common, 5. And they both have an x. The biggest x I can take out is one single x. So 5x times what gets me this first term, times an x, plus 5x times what gets me negative 10x? That would be a negative 2. So 5x, x minus 2, if I write as a subtract. Write the factored form of the area. Ta-da! We've got it. There it is. 5x times x minus 2 says, what is an expression for the length of the flag in terms of the width x? So we want to come up with, what is this length? I know area of a triangle is length times width. And we know the width is x, so length times x. And we know that this final area is equal to that guy. So I'm trying to figure out, what am I multiplying by x? Well, there's my x right there. There's my width right there. So I'm taking x, I'm multiplying it by 5, and I'm multiplying it by x minus 2. If I take 5 times x minus 2 times x, the width, I will get back to this area, because that is the expression for the area. So my length would be 5x minus 2. And it wants an expression for the length in terms of the width x. So yes, my length does have an x in it. What restriction is placed on the possible values of the area? Okay, so this is kind of talking about that range idea. What kind of values can I get out for my area? Well, negative area makes no sense. So the area has to be positive. It also can't be 0. Can I have a 0 area? No, the figure wouldn't exist if the 0 is area. So it has to be positive, not 0. So I could write the area has to be, well, that's greater than 0, right? Has to be greater than 0, somehow greater than 0. It could be an infinitesimally tiny, tiny flag and have a super small area, but it can't be so small that it's 0. So the area has to be greater than 0. So what restriction does this place on the possible values of x? Well, if my area has to be greater than 0, well, then x can't be 0. Because if x was 0, 0 times negative 2 times 5 gives me a negative area. So x can't be 0. And then here we have x minus 2. We can't have a negative area. So x minus 2 can't go to like negative. Like if I put a 1 in, I'm just thinking of hypotheticals. So if I put a 1 in, if x is 1, 1 minus 2 is negative 1. So then I'd end up getting 5 times negative 1 times 1, which is a negative area. An area can't be negative, which then means that my x can't be 1. Can it be 2? Can my x be 2? We'd have 2 minus 2, which is 0. So then I'd have 5 times 0 times 2. If x was 2, that won't work. I'd have an area of 0. So that x has to be greater than 2 because of this factor. My area can't be 0 or negative, so this x minus 2 makes sure that our x has to be greater than 2. So that's the restriction it puts on x, since area cannot be 0 or negative. Okay. All right, so now we get into the meat and potatoes of this section. Is factoring when that leading coefficient's not 1. Hey, remember, flashback, when the leading coefficient was 1. When the leading coefficient was 1, we basically just had to look for the factors of the constant term that add to get me what we call the linear term, just the x term. So we looked for factors of this that add to give me that. This number up here is going to throw a monkey wrench in that. We can't use that process anymore, but we still are going to use the factors. So, and this is a slightly different way from the textbook. I believe the textbook's version of this is a little confusing. But again, we're still going to list factors of C, because that's still, that second term is going to have to be factors of C. But then I also need to find factors of A. So I list the factors of A. I list the factors of C. And then basically you guess and check until you get that middle term. So those factors give you what things to try. And then you guess and check. So first step is you get those factors. Second step, you guess and check. And heavy on the check. You just check it. You're going to get really good at multiplying these things. Okay. And some people are just naturally better factors than other, the people who are really good at multiplication. Okay. If you're not great at multiplication, that's fine. You can still factor. It just might take you a little longer on some of that. Okay. Right. So let's go ahead. Let's put this principle in action. So here I'm going to factor 6x to the second plus 13x plus 5. First, always make sure it's in standard form. Okay. If it's not in standard form, first, standard form. If it's not in standard form, you need to get it in standard form. Then second, look for common factors. Always factor out those common factors first. What we did up here, factor out those common factors. Like if they both have a factor of 3, factor that guy out. If they both have a factor of x, factor that guy out. So second, look for common factors. And if there are no common factors, then we start our factoring process. So first is this in standard form, x squared x. Yep. Look for common factors. Okay, these two have x's, this one doesn't, so that doesn't work. Factors of 6, 2 and 3, 1 and 6 are not factors of 13 or factors of 5. So those first two boxes are checked. So those are the first two things we look for. If that isn't the case, then we're going to go ahead and we're going to list the factors of 6. 1 and 6, 2 and 3. And we're going to list the factors of 5. 1 and 5. Okay. Now we set up, I always just start with my parentheses. And I'm going to use these factors for the first terms. Okay. So for example, I would use 1 and 6. So we're going to use 1x and 6x. Just try one. So I used the 1 and 6 first. And then, well, the only factors of 5 are 1 and 5. Okay. So we'll go ahead and we'll do those. So let's do the 5. Oh, let's get rid of that. Those aren't negatives. This is strictly positive. All of them are plus, 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 so we don't have to worry about negatives. So let's go ahead and let's use 5 and 1. And all positive. Okay. So here I'm just guessing. So first I list the factors. So here's me listing the factors. And then now I'm guessing. Again, keeping in mind, these first ones come from here. These second ones come from here. And then now we multiply it out. Okay. So now we multiply it out. So we would have 6x to the second plus x plus 30x plus 6. Sorry, plus 5. 5 times 1 is 5. Okay, so my 6x to the second worked. That gave me that first term. My 5 worked. Now we need to look at middle term. When I add these, I get 31x. What am I trying to get? 13x. Did it work? Nope. So I'll be like, nope, didn't work. So we mark it somehow to show it didn't work. A lot of times I just look like nope on the side or kind of just do a this. Do not completely erase it. You do not want to lose track of the things that you've tried. Okay, so that was us trying. So we might jump to, okay, now let's try 2 and 3, but stop. Before you jump to new numbers, switch the numbers around. We had the x with the 5. Let's put the x with the 1. Let's switch them around first because that might do it. So now we're going to try it again. But instead of x plus 5, let's do x plus 1. And then 6x plus 5. Okay. And again, we distribute that out. So x times 6x is 6x to the second. X times 5 is 5x plus 6x plus 5. So we end up with 6x to the second plus 11x plus 5. We're closer. First terms work, second terms work, but that middle term is not working. We want to get to 13x. That will give me 31. Okay, so that one didn't work either. So we're like, nope. Okay, so we tried the 1 and the 6 with the 1 and the 5. Those didn't work. So now let's go to the 2 and the 3. So if I had room, I'd keep working down my paper. So then we'll try 2x and 3x and 1 and 5. Okay, so now we distribute 2x times 3x, 6x to the second plus 10x plus 3x plus 5, 6x to the second plus 13x plus 5. Did we find it? There's my 13x. I want to get to 13x. We found it. So be careful. What a lot of people will then do is circle this and be like, yep, I'm done. Okay, that's the problem. Okay, this was us checking our work. The actual answer, and here I'll put it in a different color. We'll put it in orange. The actual solution is 2x plus 1, 3x plus 5. Those are the factors that I multiply to give me this. Okay. And since multiplication is commutative, meaning the factors can move around, if you end up with 3x plus 5 times 2x plus 1, it's the same thing. The factors are just the other way around. If I multiply these, the only thing that matters is that the 3x and the 5 are together and the 2x and the 1 are together. Okay. All right. Okay. Next one, task 3. Again, same process, but here we throw in a negative. The process is exactly the same, but now we have to consider what positive, like where the positives and negatives go. So first, I make sure it's in standard form. X to the second, x, 15. Yep, we're good. Then second, always look for those common factors. Factors of 2, let's see, 7 doesn't have a factor of 2, neither does 15. Okay, nope, they don't have any common factors. So now we go ahead, list the factors of 2, 1 and 2, the factors of 15, 1 and 15, 2 and 3 and 5. Okay, so now we do some guessing and checking. So 1x and 2x plus 1 plus 15. Give it a go, see what happens. But if you notice, oh, let's go ahead, let's multiply it out. So we have 2x to the second. We get plus 15x plus 2x plus 15. Okay, and we may have missed it. This is a negative. I need to get to a negative 15, which tells me one of these two has to be negative. So let's go ahead and let's try the one as negative to start. So that's going to change things up a bit. So we have 2x to the second plus 15x minus 2x minus 15. So when we go to add these, 2x to the second plus 13x minus 15. Again, our goal is we want to get to a negative 7. Again, that's a negative 7 plus a negative 7 plus a negative 15. So I got to 13. Okay, so what if we flip-flop these around? So that one didn't work. And I want to get to a negative 7 there in the middle, so I don't know, maybe flopping these around will work. So x plus 15 and the 2x and the negative 1. Okay, now let's try it. 2x to the second, negative x plus 30. Okay, way too big. I want to get to 7. And then a negative 15. So I can tell there my middle term there is going to be 29x. Nope, that one didn't work either. All right, so what about if we use the 3 and the 5? Okay, so those are our possibilities for the 1 and 15. So let's do the 3 and the 5. So we would have x plus 3. X. Oh, we need a negative. Want to make the 3 negative? It doesn't matter which one you start with. You're going to flip it around anyway. If you might get lucky and hit it first try. There are some people that just hit it first try. Oh, we're missing the 2. 2x. Because 1 and 2. So now we distribute 2x to the second. Again, we're going to do a lot of multiplying. Plus 5x plus a negative 6x plus a negative 15. So we end up with 2x to the second. That gives me a negative x in the middle. Nope, that one didn't work either. Okay. Again, don't give up. Flip them around. X, let's do plus 5. And 2x plus a negative 3. So 2x to the second plus a negative 3x plus 10x. Ooh, did we find it? Almost. Negative 3 plus 10 is positive 7x. I want to get to negative 7x. Thoughts on how to fix that? My negative and positive are in the wrong spot. So we're going to go ahead and do it one more time, but instead we'll do x and the negative 5. We'll make the 5 negative, and 2x will make the 3 positive. So now we multiply it out, 2x to the second plus 3x minus 10x, and then there's our negative 15. There we go, that's negative 7. So this is going to factor into x minus 5, 2x plus 3. So there's what we multiply to get to 2x squared, negative 7x, negative 15. Okay, lots of fun. Okay, look at all the different things that we tried here. Okay, so this one was really close, except for, of course, that positive. It's positive 7, and we want negative 7, so we had to switch them. You might get lucky, and the second one you try might hit it. Okay, you will start getting better at noticing, like, how big. Like, noticing, like, here in the middle, it's not very big, so I wouldn't want to multiply the 2 times the 15. Okay, you'll start noticing that and getting better at it, but really all it takes is a lot of practice. There really isn't like a clear cut if this happens, if that happens. Okay, very last one. So here we have an in-ground pool is being installed with a concrete path of uniform width on all 4 sides. Meaning, uniform width, meaning it's going to be the same width across all of here. It's always going to be x. So let's go ahead, and that'll be x, and this will be x. Okay, it's going to be that same distance all the way around. The pool, along with the concrete path, will have a total area of 96 square meters. So the area inside the whole entire thing, so the area inside this whole entire thing is 96. So the area inside this whole thing is 96 square meters. Okay. What is the width of the path? Okay. Well, this whole entire thing is a rectangle. So area of a rectangle is just length times width. So here's my width. Here's my length. I just need to find expressions for those. So I need to know how far is it from here all the way down to here. Well, I know from here to here is x. From here to here is 5. And then from here to here is also x. So the whole distance would be x plus 5 plus x, which if we put together like terms, x and x gives me 2x plus 5. Now we can use that same process to find the length. From here to here is x. From here to here is 9. From here to here is also x. So again, I would have x plus 9 plus x, which is 2x plus 9. And so the area of that whole thing, area of a rectangle's length times width, that area is 96. The length is 2x plus 9 times the width, which is 2x plus 5. I need parentheses here because without them, I'm only multiplying those two things. So parenthesis, parenthesis. Okay. And I need to figure out what the x is, because if I knew x, then I would know the width of the path. So this might look factored. Well, and this kind of is factored, but it equals 96. For me to apply my solving methods again from the last section, for me to use the zero product property, it has to be equal to 0. It has to be equal to that 0. So I'm going to need to set this equal to 0. So to do that, I'm going to need to distribute this guy out and then move that 96. So let's distribute this guy out. 2x times 2x, 4x to the second. 2x times 5 is 10x. 9 times 2x is 18x. 9 times 5 is plus 45. And that's going to equal 96. Let's put together like terms. 10, 28x plus 45, and we're going to subtract the 96 to the other side. So 4x to the second plus 28x. We have a 45. We're going to subtract 96. 45 minus 96 is negative 51 equals 0. So now I'm going to solve this. This is now a quadratic, x squared. So to solve it, I have to factor it because I have to use the zero product property. So the leading coefficient's not 1. So I need the factors of 4. 1 and 4 and 2 and 2. Oh, the factors of 51. 1 and 51. I don't know them, so let's just try. It's not even, so 2 won't go. What about 3? 3 and 17? Okay. And we can try some others, but both 3 and 17 are prime. 4, 5 won't go. It doesn't end in a 5 and 0. 6, 7, and then now we're back to this number is divided by is almost, it's bigger. Like if I go 8, oh, sorry, 51 divided by 8. So now we're smaller than 8. So I know if we found them, we found them all. That's all of them. So now we trial and error this. Okay, so sorry if I don't have much room. I'm having to go to the second page. So I don't know which one. Again, we can pick whichever one we want. You don't have to start with the first ones first. Okay. But I do know that this is a negative 51. So I'm going to put I have to think of the negatives on there. I think I'm going to start with the 2 and 2. Main reason is this number in the middle isn't very big, and multiplying by 4 might make a number too big too fast. So, I'm going to pick the like more immediate numbers, like the smaller numbers, and then I think I'm going to do 3 and 17. Just because, again, this number here in the middle is not that big. 28 is not that big. So I'm thinking a 51, which is going to make it, like I'm going to have to multiply that 51 by 2. It's going to make it too big. So we'll do a, I don't know, a negative 3 and a positive 17. Again, I have to have a negative on it, negative 51. Okay, let's go ahead. Let's multiply it out, see if we hit it. So 4x to the second plus, I don't know, 2 times 17, 34? I'm pretty sure. Negative 6x, negative 51. Did we hit it on the first try? 34 minus 6, 28. We did. Looky there. 4x to the second plus 28x plus a negative 51. We did. Good job, guys. All right, so here we're not done. We just found the factor. So now I know that this factors into this. So now I have to set each of these equal to 0. So 2x minus 3 times 2x plus 17 equals 0. So now I set each factor to equal to 0. 2x minus 3 equals 0, or 2x plus 17 equals 0. I need to see this step in your work. I need to see that you fully understand the zero product property and what's happening. So if I do not see that, I will send you back to the table and you will put that step in. So write it out. So then now I need to solve this. So each of these. So I'm going to add 3 to both sides. So 2x equals 3. Divide both sides by 2. So x equals 3 halves. Or here we subtract 17 from both sides. Ooh. 2x equals negative 17. Divide both sides by 2. X equals negative 17 halves. So we're looking at, again, don't lose track of this problem. We're looking for how wide that is. A negative width makes no sense. So that negative width does not make sense in this problem. So does not make sense. So the length of my, that is not how you spell sense. S-E. Does not make sense. So the length of my pack is 3 halves and my units is in meters. So 3 halves meters, which is 1.5 meters. If we divide 3 divided by 2, 3 halves, 1.5 meters wide. So my path is going to be 1.5 meters wide.